Alright, today we are jumping into projectile motion, which is throwing objects and gravity, causing them to come down. So, we're going to start with some information. So first off, what is projectile motion? When an object is dropped from a certain height, gravity causes it to fall at a certain rate. On Earth, that rate is set. If you leave this planet, or you change the units, that rate, that number, is going to be different. When an object is thrown, there's an extra force involved that either works with or against gravity, but gravity usually wins. This extra force is called initial velocity. We use v naught or v subscript 0 to represent it. V naught is positive if the object is thrown upwards. V naught is negative if the object is thrown downwards. So the formula for calculating the height of any object, thrown or falling object on Earth when measuring in feet per second, feet and seconds, sorry, my bad, is h of t, meaning the height is a function using time as your input, is going to be negative 16 t squared plus v naught times t plus h naught. H naught is h subscript 0, so again it's just that starting height at time 0. V naught is still initial velocity, t is the time in seconds, and h of t is the height of the object relative to time in seconds since it's been thrown. So looking here, our first example, we have a baton twirler. Beautiful baton twirler, you can see them in the left. The baton leaves the twirler's hand 6 feet from the ground. So here is our initial height, 6 feet. So I'm going to put over here, I'm going to say h naught equals 6. And has an initial velocity, how nice of it to tell me exactly what that is, of 20 feet per second. So our v naught is 20, so this is 6 feet. This is 20 feet per second. The twirler catches the baton when it falls back to a height of 5 feet. So our ending height is 5 feet above the ground. So time to 5 feet is what this should say. How long until the baton reaches the max height? So what is max height? What would that look like in this parabola? What is the max height? So how tall did it get? And for how long is the baton in the air before it hits 5 feet? Because it gets caught before you hit the ground. All right, so our time to max height and our max height, these are just the vertex. These are the vertex of the graph. Now, if you think back to Unit 2, it clearly says of the, right there. We figured out how to find, from standard form, the vertex. To find the x, or in this case t, or time, you're going to do negative b over 2a. Then to find the max height, you would plug that number, whatever you got by doing negative b over 2a, into your equation. So let's set up the equation first. So our equation is going to be negative 16 t squared, and then our v naught is going up, so it's going to be positive 20 t, and then our initial height is above ground, so we're going to say plus 6. Alright, so then a is negative 16, b is 20, and c is 6. So if we want negative b, so our time is going to equal negative b over 2a. So this is going to be negative 20 over 2 times negative 16, which we are going to use a calculator for. Alright, now with our calculator, we can do our negative 20, and then I'm going to turn it into a fraction, over 2 times negative 16. And we're going to get 5/8. I actually want that. Well, actually, that's fine. We can use 5/8. So we get 5/8. And I do actually want that as a decimal. I lied. So we're going to turn it into a decimal, which is 0.625 seconds. So a little over half a second. Okay, so now we need to plug that into our equation. So our equation is negative 16. I'm going to use the 5/8 because that's a little shorter to write. 5/8 squared plus 20 times 5/8 plus 6. And again, we're going to use the calculator. So we've got our negative 16. Then in parentheses, I'm going to put the 5/8. And then I'm going to say plus 20 times 5/8. Oh, I forgot a squared. Oh no. Put the squared there. And then we can come put our parentheses. Perfect. All right. Plus 5/8 plus 6. Hit enter. We get 49/4. So h of 5/8, which is our time to max height, is going to be 49/4, which is the same as 12.25 feet. Okay. So now we found the time that it takes to reach max height, a little over half a second, and we found that max height to be 12.25 feet in the air. So now we want to find the amount of time it takes for it to hit the ground. So we know that the ending height, when she catches it, well, not the ground, 5 feet, is 5 feet, because that's when she catches it. So we're going to have 5 equals, and we've got our negative 16 t squared plus 20t plus 6. Now this looks super familiar to something we did in the last unit. It almost looks like we could solve it using the quadratic formula. I know you're so excited. So, but in order to use the quadratic formula, it has to equal 0. So we're going to go ahead and minus 5 from both sides. And we get negative 16, which I tried to make a single number. So 0 equals negative 16t squared plus 20t plus 1. So then that means A is negative 16, B is 20, and C is 1. You ready for our beautiful song? I know you are. You should sing it with me, even though I can't make you on the other side of your computer, but you should sing it with me. We've got, in this case, it's t equals, so I'm going to change the beginning. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and I'm going to use my calculator to do this because even though I can get an exact answer, an irrational answer here is perfectly fine. The computer is actually expecting an irrational answer. So I'm going to make my fraction. I'm going to go negative 20, and we're going to start with the plus equation. Then we're going to do square root of, and then we're going to do 20 squared minus 4 times negative 16 times 1 all over 2 times negative 16. All right, when I plugged that in, I got a negative 0.048 seconds. That doesn't make sense in terms of the problem. So let's try the other one. So no negative times. So let's come up here. Let's change our plus square root to minus square root to get the other answer. And this time we get a positive 1.298 seconds. That makes a lot more sense. Okay, so that was a lot of work for a single problem, but now you get to do this one. So you have a volleyball game, things are happening. Know that when they spike the ball downward, that's going to make your initial velocity negative. And we will come back together after you have finished that problem up, and we will talk about what happens when we talk about meters.